Thank you, Dr. Lee. Thank you for the opportunity, and thank you to the SMTA Penang chapter for allowing us the opportunity to speak to you tonight and to teach you a little bit about the electrochemical nature of and failure mechanisms that can occur from different residue contaminants. So we'll be talking a little bit about that today, and we hope that you'll find the presentation to be interesting. If you look at our agenda today, what we're going to lead off with is where are defects introduced to electronic hardware. We'll talk about what you can't see will hurt you. We'll speak to the role of cleanliness as a function of reliability. We'll also talk about developing the cleaning process. We'll move into cleanliness test methods, industry standards, and then we'll conclude the talk tonight. Both Ram and I will be giving this presentation, and we will be handing it off to each other. So again, thank you for giving us the opportunity. When we speak to where are defects introduced into electronic hardware, there was an interesting study that was published by Sandia Labs back in 1997. And they made an interesting point. And the point that they made, and if you look at this image here, it talks about the percent locked in cost. And what they're really saying is that if you go and look at product quality, reliability, and durability early in the design phase, the cost of that work into your designs is much less than if you do it into the assembly or the production phase or once the device gets out into the field. And so today we're going to talk about different areas where the complexities of electronic circuits have arisen, and some of the areas that that you can do at your site to look at these designs early into the process to understand them better from that standpoint. If we look at failure resolution, the problems found downstream have to be fed back to earlier groups for resolution. And if we think about the cost of engineering today, and different people who are on the call who are process engineers at your company, each of you know that when a problem occurs, it takes a significant amount of your time and effort to understand that and to say, how do we resolve it? But again, we're going to try to teach a little bit tonight about how can you gain some upfront knowledge on how and why failures occur and understand the failure mechanisms. When we think about different wear out mechanisms on electronics, this is something that each of you all know. One of them is chemical contaminants. Another area is mechanical, and a third area is electrical. These are the key areas. But tonight's presentation is going to focus the teachings on chemical or contamination failure mechanisms. I'm going to turn it over to Ram, and Ram's going to talk about what you cannot see can hurt you. Ram?
Oh, thanks, Mike, and good morning to everyone that is on the call. When we think about these reliability, we've been looking at flux in the assembled devices for decades, but with through-hole components and larger sizes, you were able to see that residue. What we're talking about really now with electrochemical reliability, the concern is more down on a component-specific challenge because of these leadless devices and BTCs, or bottom termination components, where the flux is trapped underneath and may not properly outgas. And what do we mean by outgas? We'll talk about that in a second. Hopefully we have a video that may play here. But those residues that those ionic species may not fully activate. And if they're left behind under there, Mike, if you want to move to the next slide, under these components, what you have is an anode and a cathode right here in the middle, and you have these ionic species, and in the presence of moisture, they can mobilize. And when those ionic species mobilize, that's when the real danger comes in, and we'll talk a little bit more about that. Mike, do you want to, well, let's see if the video plays here. What you're looking at is this chip cap is going through a reflow cycle, and you can see some bubbles forming there, and that's that flux as the achieves the melting point. The flux residue is actually the solvents are volatilizing. They have to outgas and escape, and it reduces the volume of that residue and allows it to polymerize into what we typically see as that no clean residue.